A composite function is where the output of one function is used as the input for another. So here we've got f of x is 2x plus 3 and g of x is x squared. What we're being asked to do here is first of all to substitute 4 into g of x and then use the output of that in function f. So we'll do that step by step. So if we substitute 4 in, we've just got 4 squared, which is 16. We then use this output as the input for f. We've got 2 times 16 plus 3. We need to be careful we do this in the correct order. Here we've got to do f of 4 first, and then we use the output of that in function g. So f of 4 and then we use that 11 and this answer here is this, g of f of 4. Now we can use the same function twice. So here we've got f of 4 to start off with, which we've already done up here. We know that's 11. Then we're going to use that output as the input. So we've got 2 times 11 plus 3 gives us 25. Pause the video, have a try at these three. So this time our functions are f of x is 2x squared, and remember that means 2 times x squared. And we've got g of x is 5x minus 3. So first step here, f of 2 would be 2 times 2 squared, and we use that output in our function g. For the second one, we're starting with function g. And then we're going to use that in function f. And the final one, we're going to use the same function twice. So g of 2, and we've seen up here, that's equal to 7. So we can see with these how we use a composite function for a given input. Pause the video, have a try at these. So we've got 5 different functions up at the top. We're given a compound function and we've got to find the answer somewhere here. Some of these answers are repeated, like there's 2 3s. That means 2 of these functions above will have the answer 3. Once you've done that, you can have a try at this extension. Pause it, come back for the answers. We're going to keep looking at using composite functions, but here instead of having a numeric value in here like we were looking at last time, like f of g of 2, where we use 2 as the input for g, and then the output of that we use as the input for f. We've just got the variable x in here, so we're going to end up with an expression not with just a numeric value. So let's see how this works. We're going to start with g of x. Now we're told that's just equal to x squared. If the input's x, the output is x squared, so we've done the first bit. Now we need to use this output as the input for our next function, which in this case is f. So if we look at the function for f, where we've got the x, we're just going to replace that with x squared. So f of x squared will be 2 lots of x squared plus 3. all we've done here is we have replaced the x here with x squared because that's what we're using as our input. Second example, we're starting off with f of x, which we know is 2x plus 3. We're going to use this output as our input for the next function. So we're going to substitute in 2x plus 3 in place of x here. So we're just going to square that. And sometimes in a question, it's okay to leave it like this. Often you will need to expand the brackets because there'll need to be more you have to do with it. The last example, we've got repeated function here. So we know that f of x is just 2x plus 3. We're going to use this output in place of x. So we'll get 2 open brackets, 2x plus 3, close brackets, plus 3. And here, this is all a bit of a mess, so we do want to tidy this up. So we've got 2 times 2x, 2 times 3, and then we're adding that 3 at the end. And tidying this up, we get 4x plus 9. These 3 questions are really similar. This time we've got the functions f of x is x squared and g of x is 5x minus 3. Pause the video, have a try. So we're starting here with f of x, which we can see from the top is just x squared. And we're going to use this output as the input for our next function. So where we have x here, we're just going to replace that with x squared. So we'll have 5x squared, take away 3. Here we're starting with g of x. And you don't have to rewrite this every time, but I find the thought process can be useful. And we're going to use this output as the input for our function f. So in place of x here, we're just going to put 5x plus 3. So that's going to be all squared. If we did want to expand those brackets, remember you have different methods. You have FOIL, you can use the multiplication grid, or you can use the smiley face method, where we just use the lines to show that we're multiplying everything across. So 3 good methods here, they all work really well. It's just a case of finding which one suits you best. And if we do expand those brackets, we're going to end up with 25x squared plus 15x plus 15x plus 9, which we can tidy up. The last example here, starting with g of x. And we're going to use this as the input for function g again. So in place of x, we're going to be putting in 5x minus 3. So we'll have 5 times open brackets, 5x minus 3, close brackets, minus 3. We'll expand these out, so 5 times 5x, 5 times negative 3, take away 3, and tidying that up gives us 25x, take away 18. Now this example I think is really useful practice, but one tricky thing with it is sometimes these answers which are given here aren't in the form that you first get. So we need to be a little bit careful with that because it did cause a few problems in class. You can either pause it straight away now, or I'll talk through a couple of examples here. So for the first one, we want f of g of x. Now, ideally, these should all be lowercase. It's not great, the formatting on this task, but I do think it's a useful task to practice. So we're starting with g of x, which we can see is just x squared. And then we're going to use this as the input for our next function, which is f. So substituting x squared in place of x, we'll just have 2x squared plus 6. So that is what f of g of x is equal to. And we should be able to find that in our answers here. Yep, so it's just this one here. Like I say, some of the others don't match on first look. I think question 3 was one of the tricky ones here. Let's try that. So that's g of h of x. So we're starting with h of x, which is equal to x plus 3 squared. And then we're going to use all of that as the input for function g. So for function g, we're going to square this. So we've got x plus 3 squared, all squared. Now that's the same as x plus 3 squared, oh I haven't quite left myself room here, times x plus 3 squared. And remember, when we've got the same base and we're multiplying it, then for the powers we're going to add those. So we'll get x plus 3 all to the power of 4, which is this one here. So pause the video, have a try with these. There's also an extension task here. Let me just get rid of the workings that are over the top here. We're going to move on a bit later to look at questions like these, so don't worry if you don't get a chance to now. And these are the answers for the task you've got here.